All right, so earlier in this problem, we drew the bar and we drew the forces that were acting on the bar. We had the little mg from the sign, we had the tension, we have big mg from the weight of the bar itself, and then we had two forces being exerted on the bar by the hinge. One of them I called the horizontal force, and one of them I called the vertical force. All right? And in part B, we found out what T was. So we know what T is, and we know what the two mg's are. They were given in the problem. And now we're being asked to find what the vertical force and the horizontal force are. And I think the best way to do this is with those force balancing equations that we wrote earlier but we didn't use. So if we just look at the x equation, there are only two out of these 1, 2, 3, 4, 5 forces, only two of them that have x components. There's the horizontal force that points to the right, so I'll just call that h. And then there's the x component of the tension. You remember this angle here is 35 degrees. So the x component of the tension is going to be t cosine 35, and it's negative because it's going to the left. And we know this has to be equal to 0 because the bar is not moving. So since we know the tension and we know what cosine 35 is, we can easily calculate the horizontal force. Now, for the vertical force, now we have to add up all the vertical components. So we have the vertical force pointing up. We also have the vertical component of the tension, which is going to be positive because it's up. So that's going to be T sine 35, because it's pointing up. And then we have the two weight forces, and they're both downward, so I'm going to put them both negative. And this is going to turn out to be equal to 0 because, again, it's not moving. Since we know the tension, we know sine 35, we know the two weights, they're given in the problem as weights in newtons, we should be able to calculate the vertical force. If when we do that, we calculate V equals and it turns out to be negative, that's going to mean that we were wrong about thinking that it points upward, and in fact the vertical force might point downward. So you'll figure that out when you calculate this to see whether yours is negative or positive, and then you can adjust that other part of the problem to get the right answer.